Good evening, everyone. Let me introduce our convener, co-convener, chairman and co-chairman. First of all, let me introduce our chairman, Mr. Subramaniam Chandrasekhar. He is a lead fellow and carries out design consultancy in the field of HVAC&R, intelligent building management system and sustainability, with a background of over 40 plus years of professional experience in this field. Has also served as a senior trainee and trained academy in his previous assignments. I would like to introduce our Vice Chairman, Mr. V. Sridhar. He is a first-generation entrepreneur with an extensive experience in the HVAC and refrigeration industry, known for his technical expertise, leadership, and business acumen. He is also actively involved in skill development, conducting HVAC training programs for engineers and hands-on technician training in air conditioning services and maintenance. I would like to introduce our convener, Mr. Sheshadri, who is having 40 years of experience in the HVAC industry and is a certified energy professional. He is currently providing consultancy services and performance auditing under the name and style of Mrs. EnerSafe Solutions, operating across India, Africa, Asia, and Middle East. I would like to introduce a co-convener, Mr. Sendilraj. He is a seasoned HVAC principal consultant with over 30 plus years of hands-on industrial experience, known for his deep technical expertise, dynamic leadership, and results-driven MEP solutions. He has successfully engineered and delivered complex HVAC systems across healthcare, academic, commercial, and industrial projects.
CoOL Conclave majestically moves to Coimbatore in Tamil Nadu for its third edition. Tamil Nadu has been at the forefront of India's industrial and economic growth. A state that doesn't just dream of sustainability, it acts on it and has pioneered great initiatives in this direction. Welcome to Coimbatore, the industrial heartbeat of Tamil Nadu, a city built on innovation, powered by industry and guided by the progressive and sustainable approach of industrialists. Known as the Manchester of South India for its textile legacy, Coimbatore has evolved into a multi-sector powerhouse, home to engineering giants, inspiring entrepreneurs, the mixer-grinder revolution, and a vibrant hub for healthcare, tourism, hospitality, and commercial space. Nestled at the foothills of the Queen of Hill Stations, Ooty, Coimbatore offers a unique blend of business and leisure. A green haven where eco-conscious living is not just an idea, but a way of life. Here, decarbonization isn't an option, it's imperative. From green building codes to microforests, from energy-efficient infrastructure to restored lakes, sustainability runs through the city's blueprint. As part of the smart city and carbon neutral mission, Coimbatore is leading in water restoration, solid waste management, and energy efficiency. And now, it's ready to host the event that's shaping a sustainable tomorrow. CoOL Conclave 3.0, where bold ideas meet bold actions. Where innovation, inspiration, and integration come together to shape a low-carbon future. This isn't just another conference. It's a call to action, a convergence of minds, disruptors, policymakers, thought leaders, and future shapers. Dive into transformative strategies. Explore cutting-edge technologies. Forge powerful collaborations. CoOL Conclave 3.0. Innovate, integrate, inspire. Together, let's rethink our industries, redesign our systems, and revitalize our planet. Let this third edition be a defining moment in ISRE, India's decarbonization journey. Join us in Coimbatore. Be a part of this great net zero initiative from ISRE. The future is calling. Are you ready to answer? CoOL Conclave.
Now I would like to introduce our speaker. It is a great honor and privilege to welcome Mr. S. Karthikeyan, Deputy Executive Director of the Confederation of Indian Industry, Green Business Centre, with more than 25 years of extensive experience in the sustainability, energy efficiency, green buildings, eco-labeling, and sustainable cooling solutions. He has been at the forefront of driving India's green transformation. Mr. Karthikeyan has played a significant role in the growth of Indian Green Building Council, IGBC, contributing to the development of green building rating systems, net zero frameworks, and sustainable procurement initiatives. His leadership has also been instrumental in promoting Green Pro, eco-labeling, green finance mechanisms, and low-carbon cooling technologies across industries. A respected member of several national and international committees and a regular participant in the global sustainability forums, Mr. Karthikeyan continues to inspire organizations and professionals towards creating a more sustainable and environmentally responsible future. Please join me in extending a warm welcome to Mr. S. Karthikeyan. We are delighted to have him with us today and look forward to gaining valuable insights from his vast experience and expertise. Over to you, Mr. Karthikeyan, sir.
Thank you, sir. Thank you very much for a very warm welcome as well as the introduction. I think the topic what I have chosen is aligning with your CoOL Conclave as well. Very
yes, sir.
aptly.
True, sir.
And that is in fact incidental. I was not aware of this CoOL Conclave.
Oh,
actually,
good,
I
sir.
thought, okay, decarbonization is need of the hour, and then we should speak about decarbonization as part of this initiative. And thank you very much, sir, for this opportunity. It's my pleasure to be part of this webinar and then discuss with the Unitary members. Yes. When I got the invitation from Unitary to speak about the air conditioning and the opportunities related to efficiency improvement, I told them, yes, can we have something related to decarbonization? That is how the whole presentation has shaped up. So I will go through the presentation completely.
Yes, sir. Yes, sir.
And then if there are questions, we can take it up at the end. Is that fine with you, sir?
Okay. Yes, very good, sir. Very well, sir.
Thank you.
Very well.
Thank you very much. So, friends, I will put it like this. If you look at cooling as a subject in India, it is growing at a much faster rate. In fact, if you look at in terms of air conditioning penetration in India, maybe we can say it has penetrated about 88% of the people. Still, we are in a very primitive stage. It has been always looked at, meant for people who are really affluent. But right now, it is also growing at a much faster rate. In next 4 or 5 years, it is expected to more than double in terms of number of air conditioners, especially the unitary air conditioners. When you say unitary air conditioners, mostly these are all split air conditioners in the country. So this has been driven by many aspects. For an example, urbanization is one factor which drives an increased use of air conditioners. Obviously, there is an income growth, especially in India. The middle income group people, they are aspiring to have the air conditioners at their home. So it is also growing. Third, what is very important aspect is the climate change. The El Nino effect you all might be hearing, as well as the heat wave that is happening across the globe. It is also driving an increased air conditioners use in the country. And obviously, when you use more and more air conditioning, that leads to a larger amount of emissions because of the energy consumption. So this becomes a challenge. This becomes in fact, I would even call it as a major hurdle for a country like India in terms of achieving the net zero goal by 2070. Because more is the emission, obviously you need to put more effort in terms of reducing the carbon emission and then moving towards net zero. So from this context, if you look at from air conditioning point of view, we should not only address this in bits and pieces, say in terms of addressing only the energy efficiency component, or in terms of addressing integrating renewable energy, etc. This need to be looked at from the entire life cycle perspective. That is the message I would like to pass it on today. So how this is going to matter from the entire life cycle perspective, let us see from the air conditioning point of view. If you look at what is the approach for decarbonization, in my opinion, if you from the entire life cycle point of view, broadly we can classify the carbon emissions into two aspects. One, the operational carbon emissions, which are major component of the carbon emission, which happens during the entire life of an equipment. I buy an air conditioner, install at my home. It is going to be there for next, let us say, 10 to 12 years. During the 12 years, this consumes significant amount of energy, and that energy leads to the emission. And also there may be some kind of refrigerant leak. I need to top up the refrigerant, and that will also contribute to the carbon emissions. The second component is what many a times we don't understand is what is that go behind manufacturing that air conditioner, that we call it as embodied carbon. Because for an air conditioner to be manufactured in a factory and then delivered at our home for installation, that also leads to a significant amount of carbon emission. In terms of percentage, you would be surprised. In terms of the percentage of life cycle carbon, that may not be very significant. But if you look at in terms of absolute number from the country point of view, it is very significant and it is also growing. So there is a need for quantifying the carbon emission from the entire life cycle point of view. Maybe it could be in terms of say kg of CO2 per ton of air conditioning, etc. And then start working on in terms of the strategies for decarbonization, and then work in the direction of making it a low carbon air conditioning. I won't call it as air conditioning system, low carbon air conditioning. Let us look at as a whole. So this is the way the approach need to be. So in this presentation, the kind of methodology we have adopted is, yes, as I said, we have worked on in terms of carrying out, this is an actual case study. I'm not going to talk about theoretically. This is something what we have done in our center, taking data from industry, started doing the life cycle analysis for an air conditioner. Of course, we could have chosen a large air conditioner, but what we felt is more than about 80% of the air conditioning in a country like India is on account of unitary air conditioner. That is the reason we started, though it is very small in nature, but huge in number. So we started taking 1 ton of air conditioner and then doing the life cycle analysis. Of course, there is a framework available, life cycle analysis framework. There is an ISO standard which governs or which guides the entire life cycle process, say ISO 14040 and 14044 standard. This gives you an idea in terms of how to estimate the carbon emission from the entire life cycle point of view. There are certain assumptions made because we need to estimate, when I talk about life cycle, there should be some number of years for the life, isn't it? So there are some assumptions made. Okay, we will look at about say 10 years of life for an air conditioner and so many hours of operation in a year. And what is the grid factor that need to be considered? The refrigerant loss that is likely to happen in the entire life cycle. So these are some of the assumptions we have made. And then based on these assumptions, we started doing the life cycle analysis. So I will go step by step. As I mentioned, the life cycle analysis has got two major components. One on account of the operational emissions, and second is on account of embodied carbon emission. We can go into the details of these operational emissions and the embodied carbon emissions further. So from the operational emissions point of view, there are multiple options available. Obviously, we all know if you are able to improve the energy efficiency, basically it is in terms of the coefficient of performance. If the coefficient of performance is better, obviously the air conditioners will consume less amount of energy. If it consumes less amount of energy, the emission on account of its operation over a period of 10 years will obviously be lower. So we have looked at the air conditioner, which is of about 3-star and 5-star. So a 3-star air conditioner by Bureau of Energy Efficiency is likely to consume, say, about 1650 kilowatt hour per year, which translates to about 11 approximately 12 tons of CO2 emission over a period of about 10 years. On the other hand, obviously, if you go for a 5-star air conditioner, that is likely to consume less in terms of energy consumption, say 1300 kilowatt hour per year, and the carbon emission is likely to be only about, say, 9.3 tons over a period of 10 years. So obviously, the efficiency improvement in terms of carbon emission reduction is significant. It is to the tune of about, say, approximately 20%, because the electricity is a major component. So in this electricity, if you start looking at the options in terms of the renewable energy, there is an opportunity in terms of further reducing the emission as well. This is just a small comparison in terms of how this efficiency is going to make an impact in operational emission. The second, I will talk about the combinations more in the subsequent slides, but this is an idea. The second aspect is the refrigerant. This is something very, very important. Many a times we don't talk about this refrigerant, how this is going to make an impact, because these refrigerant also have got significant impact in terms of equivalent of CO2 emission, kg of CO2. Say for an example, R410A is equivalent to, per kg is equivalent to 1200 kg of CO2 equivalent. On the other hand, R32, if you look at, it is equivalent to, is about 225 kg of CO2. On the natural refrigerant like R290, it is hardly about 0.8 kg of CO2. So the selection of a refrigerant makes a large difference in terms of the carbon emission. In fact, there are a lot of effort in terms of moving towards natural refrigerants and then trying to bring down the emissions as much as possible. But of course, there are the cost economics makes a difference, but still the efforts are more in terms of moving towards R290. But R32 is quite common. R32 is quite common, and then it reduces the emission as high as about, say, 80% compared to, say, 410A, etc. And if somebody is able to go to R290, nearly eliminates the emissions on account of a refrigerant. Ideally speaking, we should have R290, but it has got its own repercussions. I am not going to get into that. But just to give an idea, how a refrigerant can make a difference in terms of the carbon emission. Now we are going to get into in terms of this is only about the operational carbon. We will get into the further details in terms of how the combination works a little later. But I will also talk about the second part in terms of the emission with respect to embodied carbon. Embodied carbon, what we have done is, in fact, we need to understand the kind of material that go into making the air conditioner. And then we need to look at what is the weight, where it is coming up. This is a little cumbersome process. We need to, in fact, look at the breakup of the material that go into the air conditioner. We have done that based on the details collected from various manufacturers. I won't say it has been taken only from one manufacturer. It has been taken from various manufacturers. And then we weighed it. And then based on that, we started looking at in terms of how much is the emission for different materials. So if you look at the different material, we would be surprised to know majority of the air conditioners use a lot of copper. The copper, ideally speaking, I would think initially, hey, copper should have contributed more in terms of the CO2 emission, but it is not so. On the other hand, the larger carbon emission is on account of the electronics, the PCB boards that go into the air conditioner. Most of the PCB boards nowadays, they are imported from other countries, especially from Southeast Asian countries, and then used in our air conditioner. These PCB boards, because of the heavy metals you use in that, in fact, the metals are precious metals. The metals you use in these PCB boards that contribute to a large quantum of the CO2 emission. Of course, subsequently, if you start looking at aluminium makes a difference. If you use virgin aluminium, obviously the emission is significant. And steel also contributes significantly, then plastics, then insulation, and finally copper. Why copper is so low? Because copper can be infinitely recycled. So that is a major advantage. When you start recycling the copper and then using this as part of the air conditioner, the emission levels are much lower. But these are the facts in terms of the contribution from the materials. So, but if you look at the embodied carbon as such, is hardly about, say, only 255 kg of CO2 per unit for 1 TR unit. The amount looks very small. Please understand that in fact, the embodied carbon emission, if you look at the entire life cycle, it is only 2% of the overall life cycle carbon emission. So because the percentage is too low, should we not concentrate on this? We need to, because our air conditioning requirement goes very high. When the requirement goes very high, when the requirement gets doubled, tripled in next 5 years, these embodied carbon emissions also are going to make a significant difference. Then why should we work on this? Is it only because of the increase in embodied carbon emission? Not only that, when you start working on this in terms of the material, there are opportunities for the air conditioner manufacturers to reduce the cost of manufacturing even. For an example, if I have to start working on the materials, if I start looking at alternate materials, if I start looking at the low carbon materials, obviously there are opportunities for reducing the cost of the manufacturing itself. So if the material cost comes down, your production cost also will come down. That is also an incentive from the manufacturer point of view, apart from looking at the emission reduction. So in addition to that, there is an end of life stage also for an air conditioner, because the end of life stage, if you look at it, is a very small. It is mainly because the material that go to the landfill. A lot of material can get recycled. For an example, the copper will get 100% recycled in a way. That is what we understand from the industry based on the data collected. Copper gets 100% recycled, but not the other materials. The steel, aluminum, and plastics, they are all recycled only to the extent of about, say, 20%, 30%, 40%. Because the data itself is not available. Why it is not getting recycled? Recycling doesn't make business sense, obviously. If I have to recycle, let us say, plastic, it is not so easy for me to get it recycled. So it is not getting recycled. So it doesn't make business sense for somebody to work on this. So obviously, so because of these reasons, the percentage recycling is coming down. So we may have to use more virgin material for the manufacturing, and that leads to the additional emission during end of life. So these are facts. Now, having seen these facts, if you start looking at multiple combination in terms of how I can bring down the carbon emission with all these combination, what is the best that is possible? What is the worst case scenario? If you look at the worst case scenario, obviously the combination could be a very low efficient air conditioner. Obviously the combination could be a low efficient air conditioner with a refrigerant which has got the high carbon emission factor, and also which has got an embodied carbon on a very high side. So if you look at a life cycle carbon can be as high as about, say, 13.2 tons of CO2 emission. On the other hand, multiple combination, gradually you increase the efficiency. Second, you also start working on in terms of refrigerants, which has got lower carbon emission. Start looking at different options in terms of addressing the embodied carbon emission. Maybe the best possible can be somewhere around, say, 9.62 tons. So from 13 tons, we can, with the existing scenario, I'm talking about a simple existing scenario in terms of what is the best possible is about, say, 9.6 tons. So at least from 13 to 9, I can bring down by 4. That means about 30% of the emission. You need not to do anything. You can only look at in terms of the availability of the existing system and then make it some 30% reduction in emission. So this is the present condition as if scenario. So what more can be done? So this is with respect to the air conditioning system. I will also talk about some of the demand side related aspects. Obviously these air conditioners are meant for space cooling. So when it is meant for space cooling, I need to work on space in terms of reducing the heat load to reduce the air conditioning requirement also. So what are the options available? There are multiple options available. So see, I have been working in the building sector for quite some time. So we can talk about multiple options in terms of reducing the heat load in a building and then reducing the air conditioning requirement itself. Earlier, I spoke about how we can work on in terms of the air conditioning system, which is the supply side. Now we are going to work on in terms of the demand side. The demand side, if you have to work on, you have to obviously work on the building envelope in terms of improving the efficiency. When you want to improve the building envelope, we need to obviously look at in terms of what is the insulation property of the envelope, whether it is a roof or it is with respect to wall or the glazing. It need to be insulating enough in terms of reducing the heat load. Say for an example, if you look at the roof assembly, we look at in terms of what is the U value. And that U value need to be in such a way that it is able to bring down the heat gain. Can there be a kind of high SRI coating which will in fact reduce the heat gain due to the radiation? So these options now the ECBC codes are guiding us in terms of what is the kind of U value you can choose depending upon the climatic conditions we are in, depending upon whether we are in composite or hot and dry or warm and humid, depending upon the climatic condition, the U values are suggested. And according to the U value, you decide on the construction of whether it is a roof or it can be even wall. In case of a wall also the U values have been mentioned, and these U value also will vary with respect to the typology of the building. In fact, if it is a high energy intensive building, we need to be a little more stringent in terms of deciding the U value. And obviously, when we are talking about the roof as well as the wall, the insulation property of U value matters a lot. From the glass point of view, there are different parameters I need to look at. Because the glass is transparent, it allows more solar radiations also come in. So apart from the insulation, when I say U value here, it is a conductive heat transfer. I also need to take care of the radiative heat transfer here. So there is another parameter that comes into that is called solar heat gain coefficient, SHGC. That SHGC also need to be maintained depending upon the climatic condition. Say for an example, a condition like Chennai where it is warm and humid, and obviously I want a lower SHGC to reduce the heat gain. On the other hand, suppose if I'm going to a very cold condition, let us say I'm going to look at a similar building in a place like Kashmir, I may have to retain the heat. In that case, I may have to go for a higher SSGC. I may even go for a higher SSGC where I need to allow the radiation to come in and retain the heat within the building. So for that, I need to go for a higher U value. So this combination helps us in terms of reducing the heat load in a building. So once you reduce the heat load, obviously you will be able to reduce your air conditioning requirement. When you are able to reduce the air conditioning requirement, your energy consumption will come down. If the energy consumption comes down, obviously the carbon emission on account of the air conditioning itself will come down. So not only the insulation property, some of the heat load within the building also need to be taken care of. For an example, the lighting we use, it need to be really optimized. We may think lighting is only meant for illumination purpose, but these also add some amount of heat into the building. Nowadays, the major advantage is we have gone for LEDs everywhere. The LEDs help us in terms of significantly reducing the heat load, but still there is a small amount of heat load. So there is a need for optimizing the heat gain by reducing the heat producing appliances within the system. So there are two aspects. One, you have to address on the supply side. The second, you have to address the heat gain on the demand side. If you do both, you will be able to reduce the overall carbon emission on account of the air conditioning system. Now, having said this, what are the options available further in terms of reducing the carbon emission? I spoke about the operational carbon emission in the previous slide, which helps you in terms of bringing down. These are some of the simulations we have done in terms of what are the further options available in terms of moving towards a kind of net zero. That is the question now. Okay, the emissions are reduced by 30%. If you remember, the previous statement I have made was, you need not to do anything. With only an existing, the best systems available, I can bring down the carbon emission by about, say, 30%. But now, how from the 30% I can go to 100%? There are other options also can be explored. But these technologies are emerging technologies, but still it is possible. Say, for an example, there are AI-based smart controls available, which will further help you in terms of reducing energy consumption and then further reducing the CO2 emission. There can be options available in terms of pre-cooling. In an existing air conditioning itself, I can do one elimination of the moisture available in the air by desiccants, or I can look at some kind of pre-cooling technology by adiabatic cooling, and then use the adiabatically cooled air further for air conditioning. These things will help me in terms of bringing down the energy consumption further. In fact, even within the unitary air conditioners, we are nowadays trying with the innovative mechanism of, let us say, dehumidification as well as the adiabatic cooling. The final aspect is, the use of renewable energy. Use of renewable energy like solar PV integration. With that support, we can completely eliminate the carbon emission on account of air conditioning. So, okay, you will be able to bring down the complete air conditioning by, carbon emission from the operational carbon point of view. What is that we can do from the embodied carbon point of view? This is a really challenging, though it is a very small, only about, say, 2% of the total emission, but it is very, very challenging from the manufacturing point of view. Why? Because if you look at the Indian air conditioning system, you know very well, majority of the air conditioning components are getting imported, and then they are only assembled here and then supplied to us. So a lot more challenging. The electronics is a major component. How are you going to work on the electronics? The second is in terms of the steel you use. And third, the copper and aluminum. Aluminum and the copper, many a times people argue that aluminum has got a larger emission compared to copper. I agree. If you say copper has got about approximately, let us say, 1.2 kg per kg of copper, recycled copper, whereas the aluminum will have about, say, 22 kg per kg of, virgin aluminum. But on the other hand, if you start looking at a recycled aluminum, it can be even better than copper. That is where the crux is. So if you are able to use recycled aluminum is also fully recyclable. If you are able to use recycled aluminum and then aluminum microchannel based heat exchanger, in fact, it gives us a larger opportunity for reducing the carbon emission. Of course, there are challenges related to aluminum heat exchangers. Somebody may say, yes, if there is a puncture in aluminum heat exchanger, it cannot be repaired on site. Agreed. But there are options available now. Innovative air conditioners are coming up with aluminum microchannels. The question here is the industry ready to move towards aluminum microchannels? What is that we need to do for that? So that, from India point of view, if you look at, we don't have copper. We have to import more than 90% of the copper. On the other hand, we are the leaders in aluminum manufacturing. Already we have, one of the largest bauxite deposit in India. India is fourth or fifth largest bauxite producer. One of the second or third largest aluminum producer. Why not to make use of aluminum? Of course, there are difficulties, but we need to find solutions in terms of alternate materials. All your automobiles, they run on aluminum microchannels. So looking at all these options, we can think about how we can bring down the embodied carbon emission as well. So friends, this is how I would like to conclude, having discussed so far with respect to decarbonizing the air conditioning system. Just to give an idea about 1TR air conditioner, it's a summary, because with the existing system, the best of the combination, you can reduce your carbon emission by 30%. You need not to do, when I say you need not to innovate anything. Without any innovation in the best of the existing system, you can bring down the carbon emission by 30%. But there are options available in terms of further reducing it and move towards net zero. There are several efforts in this direction, and decarbonization is possible. It is not that it is impossible. It is possible if we are able to address the operational emissions by integrating with the renewables, alternate cooling mechanisms, etc. And also in case of embodied carbon, we need to become more and more indigenous, more and more we need to explore alternate materials, etc. to decarbonize the embodied carbon as well. So these are some of the thoughts I just thought of sharing with your friends. I would be happy to answer your questions. Thank you very much. Over to you, Mr. Sendal.
So it was a nice presentation, and you are so precise with data. It is amazing to notice. It was not on a vague percentage you are talking about. Precisely, you had data with you, and never we expected such a depth of knowledge what you have shared with us. And participants, I request
Thank you.
You to most welcome. Participants, I request you to type your questions in the chat such that Mr. Karthikeyan may answer your questions. If and all you have any doubts, anything, please do type on the question answer. I think it is more of a knowledge which you have shared on the data and everything. I feel the participants may not have any doubts on that, because it is all what you have given the data and what you have advised us how to reduce a carbon footprint, and how the decarbonization happens on the emission of gas and usage of air conditioners and everything. So it is all what is really happening. You have given us the data. But due to that, I feel the participants doesn't have any questions. Once again, I request, if and all you have any questions, please do type. If nothing is there, then we can end the session.
So I think my contacts are available with Ishri, sir. If at all something comes up in future, I would be happy to answer.
Great, sir. Great, sir.
Thank you. Thank you very much.
One question. Rana Veer Pratap Singh, he has raised a question. Are there studies evaluating RIBHAV, and any Indian specific studies examined the life cycle carbon footprint and unintended rebound effects of high SRI coatings, including increased reflected radiation, pedestrian thermal discomfort, or glare from reflective facades?
Okay. So he is talking about the high SRI coating. High SRI coating, it really makes a sense, but I haven't done any life cycle carbon footprint from the high SRI point of view. But our experience of having worked with the building sector, ISRI coating also you cannot apply anywhere and everywhere because it has got some impact, not in terms of the rebound effect, because whatever gets reflected, it goes beyond your atmospheric conditions. So it is not going to make a difference. On the other hand, it can be creating some kind of discomfort for the pedestrians. So you need to be careful while you are using what is the kind of SRI value. Say, for an example, if it is a roof, we recommend high SRI value of more than about, say, 75, 76%, 75, 76 high SRI coating. On the other hand, if you start using this for pedestrian system, it has to be less than 30 kind of, so that there is no glare, there is no discomfort. So that is something we need to take care. So there are, depending upon the surface, what is the level of ISRI you can go? For that, there are recommendations available.
Pratap, Karthikeyan sir has answered your questions. That is, on the roof, the reflection can be higher, and on the pedestrian or on the facade, due to the more of a glare for not to create any discomfort to the pedestrians, the reflection has to be reduced. The SRI value has to be reduced. Any other questions from any of the participants?
Somebody is asking more details about the solar PV integration. See, solar PV integration is a very simple mechanism, sir, in terms of, see, if you are using a solar heating, that's a different issue. Solar heating for your refrigerant system, that is a different setup. I am not an expert in this area. Okay, the solar PV integration has been looked at more in terms of substituting the energy consumption that is happening in case of an air conditioner with a more of a renewable energy. Okay. So that is the way it has to be looked at. And this integration, there are multiple options available at a building level. Either you can go for your rooftop, or you can go for a dedicated solar PV for your air conditioner, or you can think about even purchasing renewable energy, etc. So that at a project level, there are multiple options available. You need not to only look at it as at a air conditioner level. Okay. You need not to look at it at the air conditioner level. At a project level, there are multiple options available. And there are efforts in terms of integrating this at the air conditioner level also.
Okay, so okay. And another one participant from your name has asked, as expertise opinion, please tell us how can smart controls and building automation reduce emissions from HVAC systems?
Because it reduces your, the effectiveness. It is efficiency, it may not improve. It improves your effectiveness. You are not going to waste your, air conditioner system in terms of unnecessarily cooling the space. So for an example, a smart control will help you in terms of exactly determining when do you require the cooling, when to switch on, when to switch off, or even in terms of better control with respect to the temperature. All these contribute to, number one, in terms of optimizing the cooling itself from supply side. So when you are able to reduce the cooling itself, your energy consumption will come down. If your energy consumption comes down, obviously that will lead to the reduction in carbon emission. So it has to be looked at from that point of view.
Another one participant, Mr. Joy Shah, has asked, we have achieved good reduction of GHG emissions with respect to LED lighting. GoTo also promoted well. Is there any such innovation for mass reduction of carbon footprint for ACs? Any government promotions?
As of now, no, but there are efforts in terms of improving energy efficiency at the air conditioner level, because it has been looked at from the star labeling point of view. Number one, Bureau of Energy Efficiency increases, recommends you to go for higher star labeled air conditioner, number one. And second, the Bureau of Energy Efficiency also has made it as a dynamic. When I say dynamic, they periodically improve the overall expected performance. They so that your star labeling today, what is 5-star, it may not be 5-star after 3 years. That would become a 3-star. So the manufacturers are expected to improve the energy performance further. So obviously that would reduce the energy consumption. This is on one part. The second, there are certain demand side efforts that have been taken up by the private, when I say the power producers. They have mechanisms in terms of encouraging more and more efficient air conditioning systems to be used at the end user level. For an example, for you to purchase a more efficient air conditioner, there are incentives given with respect to how you can pay back, give back the money to the power producer over a period of time through their energy bill. So whatever the energy consumption reduction you gain, that energy consumption reduction, that energy bill, you pay back as a compensation for your initial cost. So these kind of mechanisms are not very, very popular, but they are tried, and it has been, in some parts, it has been successful. Okay, so these are some efforts. I would put it like this, energy efficiency is obviously everybody's requirement. We need not to look for an incentive. The incentive automatically comes from the energy bill.
But there is a reduction, yes.
So we need to look for obviously more efficient air conditioners for our use in the, whether it is a house or it is an office. And third aspect, what I would like to highlight is, especially in the large areas, the cooling as a service is becoming, increasingly talked about nowadays. I'm not saying it is prevalent everywhere, but cooling as a service is coming up. This cooling as a service, when I say, you don't own the air conditioner, but you get the air conditioner, air conditioning efficiently. Somebody else is maintaining the air conditioners for you, for giving the cooling in your space. So for them, the efficiency is a major tool in terms of their business. Okay, if you operate an air conditioner, you may not operate efficiently. On the other hand, that the third party, they only supply the cooling to you in a very efficient manner and then charge for the cooling.
True, sir.
So this becomes, increasingly popular in the country. We hope at some point in time this will become more popular and then contributing to, in a way, energy efficient air conditioning. And this will also lead to the reduction in carbon emission, obviously, because of the improved efficiency.
Okay, sir. Thank you, sir. And Pratap Singh has also thanked you for his for you giving his answers.
Thank you, sir.
And I hope no more questions, sir. Shall we end this session?
Yeah. Thank you, sir. Thank you very much for the opportunity.
Just a minute. Yeah. Thank you, participants. Thank you for making the CoOL Conclave webinar a success. We extend our sincere gratitude to all participants for joining today's CoOL Conclave webinar. Decarbonization roadmap for utility air conditioning in India. Your enthusiastic participation and thoughtful engagement made the session highly successful. Special thanks to our esteemed guest speaker, Mr. S. Karthikeyan, who has generously made time for this webinar despite his extremely demanding schedule. Warm regards from ISRE CoOL Conclave 3.0 team. Thank you so much, sir.
Thank you, sir. Thank you, Mr. Sandel.
Most
thank
welcome,
you very
sir.
much.
Thank you, sir.